Hello, I'm Scholastic Sam. Welcome back to my YouTube channel. Today, in the class of trigonometry, we will be talking about polar graphs. Now, the last video I made was on polar and rectangular coordinates. Now, this is the next development in that through incremental development, of course. So it's building on that. And also, it helps to know about even and odd functions. Okay, so let's introduce polar graphs. Now, when we're dealing with polar graphs like this, we're dealing with something called rose curves, which are pretty much circles where you integrate sine and cosine, and it looks like a rose with a bunch of petals. So now traditionally we have y equals sine or cosine of theta, but if we integrate polar form to include radius instead of y, we get the radius equals cosine or sine of theta. Now, that's polar form, and previously we learned about if theta was set, like they'd give us like theta 75 or theta is 30. However, in graphing this, we account for all values of theta from, from 0 to 360 or 0 to 2 pi. So it's like solves for the radius. It's like solving for the radius of a circle. You input a theta and you output a radius. So you'd get r equals the sine of theta. However, as we know from circles, and sine and cosine equations, we have to have a stretch factor, which is a, and something involving like the period or frequency, which is n. So our final equation is r equals a, sine or cosine of n theta. Let's look at the graphs of polar equations. At the top in the blue, as we see the top left, we have r equals the sine of theta. Now, this is a circle and has the diameter of 1. And it starts on 0, 0, because the sine of any angle, the lowest it can get is 0, and the highest it can get is 1. Same with cosine, which is why both of their diameters are 1. They start on 0, 0, and end at 0, 1. However, we see that sine is only in the top 2 quadrants, in the top right and top left, because, that's the sine one right here, because sine is only positive in the top 2 quadrants, and radius has to be positive. Same reason sine, as we see here, is positive in the 1st and 4th quadrants, because that's the only time where cosine is positive. Because this is pretty much, this graph right here, it's pretty much, this is 0, like this right here, and the axis is really, the right side is really 0/360, or 0/2 pi. The arc one right here and right here is really 90 or pi over 2. Here is really 180 or pi. Here is really 270 or 3 pi over 2. And over here is really 0 or 360. So, same thing for this one as well. And the a value, as we can see here, the a value is 1 because it's the maximum radius, or in this case diameter, of a circle. Because as we'll start to see when we get to dealing with rose petals, the a value is the distance from the point of origin, or the vertex, the distance from that to the farthest point away, which will be pretty much the vertex of a rose petal. Now, if the a value is negative, pretty much the x values become negative x values, and the y values become, for the sine one, negative y values, because sine deals with vertical and y values. So the positive y values become negative y values, like we see here. This one is positive, this one is negative for sine. Over in cosine deals with x values, horizontal stuff. So the negative for the cosine is reflected over the y-axis. Positive x becomes negative x. So let's go into facts about polar graphs. Now, we know we have our equations, r equals a, sine or cosine of n theta. Now, r is the radius, which is the dependent variable. It's what is outputted. Now, theta is just some angle. It accounts for all angles, hence the graph, where it's the independent variable. It's what we're inputting. Now, a is, of course, the stretch factor. Here, a is 1 because the distance from here to here is 1. The maximum radius is 1. And if it was on an axis, we'd see it went all the way up to here, which is 1. But if a was like 2 or 3, it would go out further because the maximum sine or cosine, the maximum value you can get from taking the sine or cosine of some angle is 1. And if the number 4 is in front of that, you multiply 4 by 1, of course you get 4. Now n is the tricky part. N is, of course, when you multiply by theta. Now the concept of n and all that is similar to the concept of period. For example, up here, we have r equals sine of 3 theta. That's the one we have up here in purple. So since it's the sine of 3 theta, we have 3 petals. 1 petal, 2 petals, 3 petals. Now, n can change numbers, and it can change, of course, either be positive or negative. So if n is negative for the sine, then it's reflected over the x-axis because it's pretty much saying, well, if n is negative, then it returns a negative value, which is the same as a being negative. So if n is negative for a sine, it's the same as a being a negative, which we know just reflects it over the x-axis. Now this is because sine is an odd function. Now, as we know, for odd functions, f of negative x is the same as negative f of x, which means that negative theta is the same as a negative a value. However, cosine, nothing happens when the n value is negative because cosine is an even. And as we know about evens, f of x equals f of negative x. So if theta is negative, that's the same as if it were positive. Now, this is the tricky part when looking at the number of petals. As we see up here, n is 3. And if n is odd and 3 is odd, the amount of petals is equivalent to n. n is 3. Up here, the petals is 3, the petal count. However, if n is even, the amount of petals is equivalent to 2n. For example, here, n is 4. Since 4 is even, you multiply n by 2 to get 8 petals. 1, 2, 3, 4, 5, 6, 7, 8. Let's do a practice problem. We have this equation here. We have to find out we have this graph here. We have to find out the equation. Well, automatically, we know that it has 4 petals. So n would be 4, right? Well, no, it's even. So the amount of petals is 2n. And 2n equals 4. Divide both sides by 2. We get n equals 2. Now, what is a stretch factor? Now, we see it's not on any axis, which would make it easier. However, if we drew a circle, it would intersect these 4 points right here. You know, they're not going to give you a value normally. Your teacher, someone like 1.934 as a stretch factor. So you can tell it's greater than 1, but you know it's definitely not 3. 2 is on their own here, so it seems, yes, 2 would seem about right. You have to just look and see, does it look right? It's not very mathematical, but your teacher may want you to do it without a calculator. Now, if you have a calculator, of course, you'd be able to tell. Now, we know that it's 2 something of 2 theta. However, is it sine or cosine? Well, we have to actually look at a point here. We see here that it's that it's 0, 0. So when theta is 0, the radius is 0. So is that cosine or sine? Well, the cosine of 0 was 1. So if theta was 0 and is cosine, the radius would be 1. However, as we know from our unit circle, the sine of 0 was also 0. So it would be 0, 0 if it was sine, but 0, 1 if it was cosine. And it's 0, 0, so when it was sine. So we know our equation is r equals 2 sine of 2 theta. Thank you, guys. Please like, subscribe, and turn on post notifications. If you have any questions, comments, or concerns, please leave them down in the comments section below. Thanks to my math teacher, Mrs. Barrett, for teaching me all this information. I'll see you guys next year, where I will be going over physics, computer science, and calculus. Thank you, guys. Goodbye. I'm Scholastic Sam. Always remember, knowledge is power.